In this exercise, we're going to tune PID control parameters using Simulink in MATLAB. Simulink allows us to have a process flow diagram similar to this, not a process flow diagram, a block diagram, which allows us to see the flow of information. Here, for example, we have our set point, which is compared with our PID, and the heater and temperature all go to our output that we see right here in order to control output. I should say, we see our set point, the PID controller value, so the heater setting, as well as the actual temperature, all within our Simulink setup. I want to make sure you're able to get Simulink set up right. For me, if you look right here on the left, I have all of the course in folders. Within the Simulink folder, I need to change the folders so that is the top folder. And the way I do that is just going down here. Well, it's one of the ways. We can say you could add it to path. That might complicate things down the road. So what I usually do, now I'm complicating things even more. Either way, what I usually do is I just use this file explorer up top. This is part of lesson 16, or excuse me, it's part of class 15. And then we click on the Simulink folder. All right, there we have it. I'm within the Simulink folder now of lesson 15. You can see that with the path up the top right. The current working directory is now what's here on the left. That means these files will be able to see each other just using relative paths. I'll go ahead and I'll click on the Arduino PID.slx, but let's discuss a few things here. First thing is that when we're using the Simulink model, it'll ask us for parameters in terms of proportional, integral, and derivative gains. These gains, if you look right here, are in terms of one particular constant. So whereas before, so proportional gain is equal to Kc, as we've before. Integral gain is Kc divided by tau I. So we just need to make sure that we have it in that form. And the derivative gain is equal to negative tau d times Kc. So what we'll go ahead and do, I will drag this over now. We have our set point, where we can change where our set point is. We have our PID control module. Go back out. PID control module here, where we can change. We can actually just, okay, we want more derivative than that. We'll say derivative of 2, proportional of 24, and we'll see how we did compared to last time. And finally, we need, actually, let's leave these blue. And we'll do it. We're going to set Kc equal to 5. We want our integral to be 5 divided by 120. So that would be pretty easy to do. We don't even have to do math. 5 divided by 120. And our derivative control will set to 2. Our filter coefficient, because we don't have one, let's go ahead and set that to 0, because we don't have one within our MATLAB scripts. There's also this automated tuning we can use based on a model. So go ahead and hit OK. And then to make sure that we can see what's going on, let's pull up our temperature. Here it is. Let's go ahead and run our script. You'll note we haven't changed our set point. So go back in here, we'll grab our set point, and we'll grab our temperature. And there we're off. We're off to the races. We'll go ahead and we'll bump this up to 60. And then we'll set it down later. But there you have it. You've seen the TCLab work before. The nice thing is we can see all these, again, being graphed in real time, and we can interact with them with sliders and other features. Simulink's a great tool to be able to interact with real hardware. If you have any questions on this module, please let me know.